In this module, you will learn about various network topologies, various network devices. Let us now look at various network topologies. Topology refers to the pattern of interconnection of nodes in a local area network or LAN. The topology helps in selecting the communication medium and the other network devices. Before understanding about topologies in detail, let us learn about point-to-point link. Point-to-point link, which has two ends, namely transmitter and receiver. In point-to-point link, each transmitter transmits to exactly one receiver, and each receiver receives exactly from one transmitter. Here, either single wire or separate wires are used in the transmission. Network topologies are categorized into the following three basic types, namely bus, star, and tree. Let us look at each of these topologies in greater detail. First is about bus topology. In this type of topology, each node attaches directly to a common cable. Hence, it is also called as linear topology. This common cable functions as a shared communication medium on which various nodes are attached. A device which requires to communicate with another device sends a broadcast message in both directions onto the wire that all other devices can see, but only the recipient device actually accepts and processes the message. Here, data is transmitted in small blocks called packets, and each packet consists of a header having the destination address. The destination node identifies the address on the packet and thereby processes the data when data is transmitted using the cable. This topology is considered as the backbone for a network. A bus can connect small work groups, such as in classrooms or labs, and doesn't require much cabling compared to other network topologies. Earlier, 10-base-2 thin net and 10-base-5 thick net Ethernet cabling were used in bus topologies. Bus networks are suitable for limited number of devices. If more computers are added to a network bus, it results in performance problems. One more drawback of this topology is that the entire network effectively becomes unusable if the backbone cable fails. Advantages of bus topology are: bus topology uses a very short cable length, which considerably reduces the installation cost. It has simple and reliable linear architecture. Additional nodes can be connected easily to the existing bus network along the length of the transmission medium at any point. Disadvantages of bus topology are: as the control of the network is not centralized in any particular node, it is difficult to detect fault and isolation. Repeaters might have to be used to amplify the signal if in case the central bus length becomes too long. Thus, the use of repeaters makes reconfiguration necessary. There has to be some way of deciding who can use the network at any given time, since each node is directly connected to the central bus. Next is about star topology. A star is a network topology having a central connection point called hub node to which all other nodes are connected by a single path. Here, it's of a dedicated set of wires which connects it to a central network hub. The hub becomes a central point for isolating network problems and gathering network statistics as all traffic passes through the hub. Existing information networks involving data communications or voice communications makes optimal use of star topology. For example, while installing IBM 370, multiple 3270 terminals are connected to the host system. Star topology is also used in many home networks. A star network generally requires more cable than bus topology. A failure in any star network cable will only take down one computer's network access and not the entire LAN. However, if the hub fails, then the entire network will fail. Advantages of star topology are: in star topology, failure of a single connection does not affect the entire network, and it also helps in easy reconfiguration of the network. It helps in easy fault detection. As very simple access protocols are being used in a star network, thus the central node has the control of the transmission medium for data transmission. Disadvantages of star topology are: a large amount of cable is needed, since every node is directly connected to the center, which increases the installation cost of the network. Here, if the central node fails, the entire network goes down, as the entire network is dependent on the central node. Next is about tree topology. Tree topology combines the features of both bus and star topology. Here, the network is structured like an inverted tree with the root branching and sub-branching down to the nodes. In tree topology, multiple star topologies are integrated together onto a bus. Only hub devices connect directly to the tree bus in its simplest form. The combination of bus and star hybrid approach helps in expanding the network in future in much better way than star alone. Data transmission in tree topology is similar to that in bus topology. Here, signals are absorbed by the terminators when it reaches end of the transmission medium. Tree topology is commonly used in applications that have a hierarchical flow of data and control. Let us now look at various network devices. Let us begin with modem. A modem, modulator-demodulator, is a peripheral device that enables a computer to transmit data over telephone or cable lines. The transmission mediums are analog, whereas computers operate digitally using binary language. There is no middle or halfway point when the digital signals pass from one value to another. Analog carrier signal does not change per step, so you can have all values in between, such as 0, 0.1, 0.2, 0.3, up to 1.0. To encode digital information, modem modulates an analog carrier signal. To decode the transmitted information, it demodulates such carrier signal. The main objective of modulation-demodulation process is to generate a signal that can be transmitted and decoded to regenerate the original digital data. All these processes are carried out by modem at extremely high speeds. The technology of the modem and the number of available access lines is directly related with the speed of the modem. Next is about RJ45. RJ45 or Registered Jack 45 is an 8-wired connector used to connect computers on a local area network or LAN, especially Ethernet. RJ45 connectors are similar to the RJ11 connector, except that they are wider and are used for connecting telephone equipment. Next, let us look at Ethernet card. An Ethernet card or Network Interface Card, NIC, is a network adapter which supports the Ethernet standard for high-speed network connections via cables. An Ethernet card has connections for either fiber optic cables or for coaxial or twisted pair cables. Depending on the protocol standard they support, Ethernet cards may operate at different network speeds. Modern Ethernet adapters can support the speed of up to 100 Mbps, whereas old Ethernet cards were capable only of the 10 Mbps maximum speed. At present, we use Ethernet standards, which offer speeds up to 1 Gbps. Next is about switches. A switch is a device that is used to break a network into different sub-networks called subnet or LAN segments. Switches helps in preventing traffic overloading on the network. They enable different nodes of a network to communicate directly with one another in an efficient manner. Network switches are identical to network hubs, but they contain more intelligence than a hub. It is more expensive than a hub. Unlike hubs, network switches help in inspecting data packets as they are received and therefore determines the destination device and source of each packet, forwarding them appropriately. A network switch conserves network bandwidth by delivering messages only to the connected device and also offers generally better performance than a hub. Mainstream Ethernet network switches support either 10 or 100 Mbps fast Ethernet or gigabit Ethernet, 10 or 100 or 1000 standards. LAN switches are the switches that provide a separate connection for each node in a company's internal network. Switches are mostly used in home networks and in small businesses. They do not require any kind of monitoring or configuration using external software applications and are easy to set up and require only cable connections. Next is about repeaters. A repeater is an electronic device that receives a signal, amplifies it, and then retransmits it on the network so that the signal can cover longer distances. Network repeaters regenerate incoming optical signals, electrical or wireless signals. Due to energy dissipated in conductor resistance and dielectric losses, an electrical signal in a cable gets weaker with the distance it travels. Similarly, due to scattering and absorption effect, a light signal traveling through an optical fiber suffers attenuation. Data transmissions can only span a limited distance with physical media like Ethernet or Wi-Fi before the quality of the signal degrades. By periodically regenerating the signal, repeaters attempt to preserve signal integrity and thereby extend the distance over which data can safely travel. For example, active hubs are repeaters. In case of Wi-Fi, access points function as repeaters, A repeater is not capable of doing intelligent routing performed by bridges and routers. It cannot work across multiple network architectures and also cannot filter the traffic to ease congestion. Next is about routers. A router is a network device that works like a bridge to establish connection between two networks, but it can handle networks with different protocols. The data is sent to the router, which finds the destination address and then transmits the data accordingly. Routers make sure that the data packets are traveling through the best possible paths to reach their destinations using a routing table that stores calculated paths. The sending router can determine an alternate route to keep traffic moving if in case a link between two routers fails. Routers establishes connectivity inside enterprises, between enterprises and the Internet, and within an Internet Service Provider, ISP. Routers can be wired or wireless. Next is about gateway. A gateway is a network device that establishes an intelligent connection between a local network and external networks with completely different networks. Gateway nodes refers to the computers that control traffic within your company's network or at your local Internet Service Provider, ISP. A computer server acting as a gateway node may also act as a proxy server and a firewall server. A gateway is often associated with both a router and switch. Router knows where to direct a given packet of data that arrives at the gateway, and a switch furnishes the actual path in and out of the gateway for a given packet. By performing data translation and protocol conversion, gateway expands the functionality of the router. You may have seen the term default gateway while configuring network in Microsoft Windows. A default gateway is the device that passes traffic from the local subnet to devices on other subnets. Although internal gateways for local networks also exist, default gateway often connects a local network to the Internet. You have come to the last concept of this session, Wi-Fi card. Wi-Fi cards are small and portable cards that allow your desktop or laptop computer to connect to the Internet through a wireless network. The antenna transmits the radio signals and are picked up by Wi-Fi receivers such as computers and cell phones enabled with Wi-Fi cards. Once a connection is established between user and the network, and the connection being established is a secure connection, the user will be prompted with a login screen and password. Wi-Fi cards can be external or internal. You can purchase a USB antenna attachment if Wi-Fi card is not installed internally. The Wi-Fi connection only exists between the device and the router, and most routers are further connected to a cable modem, which provides Internet access to all connected devices. In this module, you have learned that topology refers to the pattern of interconnection of nodes in a LAN. Network topologies are classified into bus, star, and tree. Modem refers to a device that enables a computer to transmit data over telephone or cable lines. RJ45 is an 8-wired connector used to connect computers on a LAN. Ethernet card is a kind of network adapter. Switch refers to a small hardware device that joins multiple computers together within a LAN. Repeater is an electronic device that amplifies the received signal and then retransmits it on the network. Router is a network device that connects two networks with different protocols. Gateway is a network device that connects two dissimilar networks. Wi-Fi card is a small portable card that allows your computer to connect to the internet through a wireless network.